This is differential equations, section 4.2. Right now we're going to do activity 421, part A. So in this section, there's these theorems at the very beginning that talk about how theorem 421, which basically says that if you have a differential equation like this, then if you were to solve this same differential equation but with a zero there, so that's called the homogeneous equation, then let me back up. So if you can find two solutions to this differential equation, and you subtracted them, then they'd be a solution to this differential equation if it were equal to zero instead, which is called the homogeneous equation. This, when it's not equal to zero, is the non-homogeneous equation. And so what that means for us is that we're going to solve this equation as if there's a zero here first. And then we're going to guess, I think it's the strategy is called something like the method of undetermined coefficients, which is a fancy name for guessing. So all we need to do, the solving for zero is going to help us find all solutions. And once we get just one solution and add that to the homogeneous solutions, that gives us all solutions for this system. Okay? So first, I'm going to focus on the general solution. So here, we're going to do the same thing we've been doing since last section. Our characteristic polynomial, r squared plus 4r minus 21 equals 0, because I'm solving the homogeneous equation. Well, two factors of negative 21 to add to 4, that would be r plus 7 and r minus 3 equals 0. So then r equals 7, negative 7, r equals 3. Are two solutions to that. So then my general solution, I'm going to say x with a little g there, that's equal to c times e to the negative 7t plus c1 plus c2 e to the 3t. Okay, now this is not a solution to this differential equation. It is a solution if there were a zero here. Now, I just have to guess and check and find one solution. If I can find one solution, I can add this to that solution, and then I'll have all solutions. So I'm going to say that again. So I can find one solution, I call that my particular solution. So if you can find one solution to this, then you can add these terms to it, and that'll give you, with the unknown C1 and C2, that'll give you all solutions. Okay? So now I need a particular solution. Well, right here, you guess based on what's here. So e to the 4t. So if you take derivatives of e to the 4t, you get more e to the 4t's. And so if you had like some constant times e to the 4t, you take second derivatives plus 4 times first derivative minus 21 times it, then you would only have constants in e to the 4t. And so when you have something like this, your guess is that the particular solution is some constant times e to the 4t. So my unknown constant is a in this case. Okay, so then xp prime, that's going to be 4a e to the 4t, and xp double prime, that's going to be, take the derivative again, you get 16a e to the 4t. Okay, so now I'm going to take these three things and put them in here and then solve for a. So putting that there gives me 16a, and I'm going to factor out the e to the 4t. Plus 4 times that is 16a, minus 21 times that is minus 21a. I factored out the e to the 4t, because each term would have an e to the 4t in it. Okay, equals 2 e to the 4t. Okay, well, 16 plus 16 is 32, minus 21 is 11. So that means 11a, and then divide by e to the 4t equals 2. So a equals 2 11ths. So then x particular equals 2 11ths e to the 4t. Okay, now this is a particular solution to this differential equation. Okay? So now, this equation, I used algebra and derivatives to find something that worked. And a lucky, not a lucky guess, but a well-informed guess. So now I can know all solutions. So all solutions are C1 e to the negative 7t plus C2 e to the 3t plus 2/11 e to the 4t. So this is your general solution, and this is your particular solution. Okay? And so that's how you would solve problems like this. Now, we're not given initial conditions here, but if we were, we would solve for C1 and C2 to find out exactly what function we're dealing with here. Okay, so that solves part A.